Hello and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Falconer, and today I'm joined by Manish Ahluwalia, Field CTO of Skyflow, and we'll be diving into the technical challenges and potential solutions to data residency requirements. Manish, welcome to the show.
Hey, Sean. Thank you very much. I'm excited to be here.
Yeah, it's great to have you here to talk about, I think, a rather tricky subject, data residency. But before we start to get into the meat of that topic, can you introduce yourself and share a bit about your background and how you got to where you are today?
Sure. So I'm the field CTO here at Skyflow. And my journey to Skyflow has been through the usual path of working as an engineer, since we are a very tech-heavy company. Most of my life I've been an individual contributor working in engineering in various different areas of engineering, everything from like big data, consumer-facing apps, infrastructure apps. My last job before Skyflow I was running security, day-to-day security operations at NerdWallet, which is a consumer fintech company here in the US. And out there I was handling security, compliance, privacy, for a consumer company. And as part of that, I was kind of exposed to what a consumer company has to deal with in terms of when you hold customer data, the regulations that apply to you, what obligations you take on in terms of security and all of that kind of stuff. So I come to Skyflow with an understanding of both the challenges that holding data creates for a company, the value that data has, and the drivers for why the company needs to use it. And of course, the challenges it creates for engineers who have to kind of build systems that work with this data and at the same time maintain a whole bunch of these security compliance obligations and all. So that's kind of what drew me to Skyflow is precisely the combination of all of these challenges and the promise that can be unleashed of folks securely handling consumer data.
Mm-hmm. Yeah. We're going to be talking a lot about, I think, data today, and in particular, the data challenges around data residency. And maybe we can start with the basics, or at least with the perceived basics, which is, what is data residency?
So there's several aspects to this question, but to this concept, excuse me. But the most important one, and the one that gets a lot of attention, particularly from engineers, is the aspect of localization. So effectively, what governments and all are saying, for very different reasons, but what governments are saying is they want to make sure that the data that is collected for the subjects or on their subjects is somehow in control of their own regulations. So whether they pass the sovereignty along to the end consumer or they want to be sovereign of the customer's data, they want to know that the data is where they can access it and they can get their hands to it if they have to. Motives vary. Governments on one end of the spectrum, like in Europe, want to make sure that their subjects' data rights are not lost because the data got moved out of their jurisdiction and out of their control. On the other extreme, you've got other governments that come with a different philosophy, and they want to make sure that they can get their hands on their citizens' data. Doesn't matter which side of the spectrum you fall on. Essentially, if you're holding customer data, your local authorities probably have an opinion on where it should live and how much access they need to it.
Right. And I think a common misconception, which you touched on, is for people who are not, experts in this field or haven't dealt with this problem before, is kind of thinking of data localization and data residency as the same thing. But in reality, localization is potentially a component of data residency, but data residency requirements could actually encompass a lot of other types of requirements. Is that right? Is that fair? Essentially,
yeah. I think you did a great job of teasing about those two concepts. Those are related, but definitely different. In some cases, there is literally a localization requirement. The government will tell you that data of a certain shape for a certain set of subjects cannot leave a particular geographic boundary. That's literally localized to to a specific geography. In some cases, they don't so much care about where it lives, but that they have access to it, or that the transfers that happen under some controlled circumstances, or follow some rules.
Mm-hmm. So it sounds like part of the motivation behind some of these requirements is around essentially those, governments or the, whoever essentially is in control of this, being able to get hands on the data if they need be. But when did these types of requirements, these data residency requirements, when did they first start?
So a lot of it is kind of as tech companies have kind of like realized their data is the new oil, as the saying goes, and gold or oil, whatever is your favorite analogy of a valuable product. As companies have realized that they can work with this data, a lot of people, communities, activists, and governments, therefore, who listen, have figured out that this is an important right for their subjects, that kind of sometimes subjects are giving up without realizing they're giving up, or subjects individually are not powerful enough to be able to confront the big tech companies. And there is also a lot of government insight into this. So, for instance, with the Edward Snowden leaks, folks realized that a lot of data in the US that lives in the US is under control or being surveilled by the US government, and that for Europe was not acceptable. Some governments, like the authoritarian ones, come from a very different perspective. They realize that all of this data that's being collected by like messaging apps, social apps, etc., is very useful for them to figure out like what their citizens are up to. So it depends on what perspective you're coming from, but a lot of it has to do with like the recent innovation and explosion in technical capabilities.
Mm-hmm. And why is the challenges around data residency such a hard problem for companies from a technical perspective?
So there are several aspects that make this challenging. So firstly, let's imagine I am building a global application I'm hoping to serve customers from various different countries. Now, what I'd ideally like is I make my decisions for where my data lives purely on technical basis. Like I have a data center running in 4 or 5 different locations. I position them around the world, mostly based on hard technical characteristics like latency between the customer and my services and things like that. Replication for making sure that geographic disturbances or technical disturbances don't mean my services go offline. Well, that all sounds great, but now governments come in and say, well, you've got customers in Brazil, or you've got customers in India or in Europe, and now you've got certain obligations for where this particular set of data lives. So now I have an orthogonal set of constraints to deal with that may work with my original technical constraints, but often do not. Because even if I have to keep data in India, let's say, I probably still want to have 2 different locations where they're stored for technical reasons of like resiliency. Now I now have a matrix instead of like just one single variable. I have multiple variables. That was an example of a problem that I know I have. Often the problem is something you don't quite realize that you have. Like, for instance, with the issue that happened with Shrens and Cloudflare, the Portuguese government was using Cloudflare not to store data, but to just move data around. And it's a fairly common, popular choice as an infrastructure provider. Cloudflare provides a very, very valuable service to you. And you may be thinking that by just putting your site behind Cloudflare, you're not really creating any data storage challenges for yourself. But as the decision concluded, Cloudflare, being a US company, is under US jurisdiction under laws that are not quite compatible with the rights for EU citizens, and therefore that was not an acceptable vendor for the Portuguese Institute of Statistics. I forget exactly the company, the organization that was using it. So you can have just when you have data flowing from your client to your services, between your different data centers, your data is probably going through all all sorts of providers, intermediaries that you do not control. And that starts creating challenges for you, because even if you thought these guys were contractually obliged to meet your security guarantees, it's not really clear that you can rely on that to be sufficient.
Right. So, even in something that's, beyond just something like Cloudflare where you're moving the data around, you could imagine a situation where you need to share data with a third-party service, say like an email relay, or programmatically send a text message or something like that. And even if your systems are set up to comply with whatever the data residency requirements are, you need to ensure when you pass that data over to these third-party services that they're also set up that way. Is that right?
That's an excellent point. You could be using third-party services like in your example, and you need to make sure that they will carry your obligations forward into their own data centers and other third, or in this case, fourth parties that they're using.
Yeah, so clearly, if you have a large system that's already been, built over a number of years, you have, maybe you've set up your systems in a certain way to solve other problems that are, deal with scalability or, speed with your customer base. This starts to get really, really complicated with trying to think about how do I re-architect this system for these, what was perhaps, unexpected, these requirements around data localization and the other types of requirements that come with the larger data residency rules and regulations. So how are companies going about trying to solve this problem? What technical solutions or options do they have at their disposal?
So the problem, of course, encompasses a whole bunch of technical problems. So let me touch on a couple of them. We talked about, for instance, like I'm collecting data from my customers and it's coming to my services, and it could be going through intermediaries that aren't uncompliant with some regulatory rules, or don't quite provide the level of privacy that I need, or security, or whatever. Well, for things like that, some of the messaging apps already solve this by performing like what's called end-to-end encryption. Now we know how to do that. We know how to do that well at scale, and that's an approach that, for instance, guarantees that doesn't matter how the data travels from the customer all the way to you, as long as it has to go through intermediaries that don't require you to kind of hand over your keys or some such thing, you can securely pass data from one end to the other end. That's what end-to-end encryption means. So that's an approach to solving that one technical problem. In general, a larger problem often in companies is not that they're worried about hostile intermediaries that are outside the company. Often the problem is just as basic as not being able to figure out where exactly you've got this sensitive data lying around. So whether it's sensitive data or not, in general, being able to track usage of a particular element of data all the way from the time it enters your infrastructure to all the uses of it and all the ways it leaves your infrastructure is not really a small problem. It becomes, of course, compounded because of these security, privacy, and regulatory complications. But that's the problem here. It's like you need to know where your data is and where it's being used, by whom, for what purpose, all of those things.
Right, yeah. I mean, if you don't know where and what you're storing, then it's pretty hard to know how to potentially shard that data and silo it within different localized data centers, because you don't know where the data is to begin with. So that's just the start of essentially your problems. So a data privacy vault is a technology that isolates, protects, governs, and allows you to actually use sensitive data. And essentially the idea is that you're moving the sensitive customer data out of your existing data center and you're putting it into the specially designed vault that's isolated and protected outside of your existing systems. And that removes the responsibility of data protection, data privacy, even data residency from your existing systems. So how does a data privacy vault help or simplify complying with the data residency requirement?
The data privacy vault, now this is of course, so far we've been talking about like problems, and now we're moving into solutions. And specifically, so far we've been talking about generalities. In this case, we are talking about like something that we in Skyflow work to provide, right? So just to be clear, the data privacy vault as an architectural pattern, of course, got nothing to do with Skyflow. You can implement your own data privacy vault or get it from someone else. Skyflow, we of course hope that you buy it from Skyflow, but irrespective of where you get it from, the key concept behind the data privacy vault architecture is that you, instead of trying to figure out and secure and manage and govern your data as it lies in your sprawling data warehouses and data lakes and OLTP databases and logs, and as you give them to your third parties, etc., the observation is that the sensitive parts of this can be isolated out, moved into the data privacy vault, and a correctly implemented data privacy vault will give you the ability to not just isolate the data, but also continue to use it in your flows, your analytical flows, your business workflows, your integration with third parties, integration between your own systems, your OLTP systems and your OLAP systems, and so on and so forth. So this in itself does not necessarily solve your problem, because sure, your data privacy vault may secure your data for you, but especially if you're running it yourself, it still is your problem. But even if you're purchasing the data privacy vault as a service from someone else, like say Skyflow, you still need to make sure that you are using this data, particularly since you are kind of like still the owner and master of your data. The end responsibility for making sure that the data got used correctly is still on you. So you still have a responsibility to follow all the data residency requirements, etc. But the data privacy vault can help make that like an order of magnitude, if not more, easier for you, because now what happens is you give your data to the data privacy vault. That's where the sensitive element lives. What you get back from the data privacy vault in return for this sensitive data is a pointer, a token in this case. And the token can have various kind of capabilities. It's not like a memory pointer in C. It's kind of like an alias, is probably a better way to look at this. And that's what you store in the rest of your infrastructure. That's kind of what you give to your third-party partner that's holding your data. And this alias can have certain capabilities that lets you perform your analytical workflows, let's say, without revealing the actual sensitive information. There's a lot of technical complexity here, and you'd have to kind of sit down and think through your use cases to figure out what's the right format of tokenization you want to use. But the essential point is that since you stored all your sensitive data in one particular object, this construct called the data privacy vault, your data residency problems, for instance, could be solved by making sure that the data privacy vault is localized correctly in the right region, or has multiple copies without your entire data center needing to be in all the places. So as an example, going back to the 3 data centers architecture you had built up because you wanted 3-way HA. So you built 3 different data centers, one in the US, one in Europe, one in, let's say, Asia, because that's where most of your customers were. Now you figure out you got EU requirements for data localization and Indian requirements for data localization. And maybe you're starting to get customers in other countries that also have their own data localization requirements. Well, you don't need to start creating 4th and 5th and 6th copies of your data center all over the world. You just get the data privacy vault in the various different locations, and your data centers, the ones that hold these anonymized, these aliases, the tokens, they live exactly where they live, and they work only with these tokens. The data privacy vault stores the data in exactly the location it is allowed to store them. So that's one way you solve the problem of data localization. If you use this in the right place, you can push the data capture closer to your clients, on your clients itself, if you have the freedom to write your client-side code, in which case the vault can be collecting encrypted data all the way from the client, and you never have to touch the sensitive data at all anywhere in your infrastructure.
Sorry for the interruption, folks, but I just had a few quick reminders. If you're enjoying this episode, please hit the subscribe button so you can always get the latest episode, and help others discover the show by leaving a rating and review in your favorite podcast app. Really helps. Last thing, before I get you back to the interview, If you are interested in the topics discussed in this podcast, then you should definitely join the partially redacted community at skyflow.com/community. There, you can meet other interesting and like-minded individuals like yourself, share your expertise, or just passively engage, totally up to you. All right, now back to the show.
Yeah, so clearly taking the approach where you're going to run, 6 different data centers to solve this problem would be operationally complex, to say the least, and probably the cost would be significant to run those different data centers, plus the resources essentially shard the data in those different siloed data centers, and then the impact that might have to your global analytics. So clearly the design pattern of the data privacy vault, being able to localize that into different areas makes a lot of sense, and then having tokens as references within the global data center simplifies things significantly. How does the data privacy vault help with other challenges around data residency, maybe like the right to be forgotten, for example?
So that's a great question. And before I start answering, I have to start off with a caveat that right to be forgotten, what exactly does it mean, is kind of something that's not a technical decision. So you have to, not a technical question, excuse me. So you would have to, of course, start off with talking to a policy expert, maybe a lawyer, your general counsel, whoever, to first make sure you understand what exactly is the requirement, and what exactly is an acceptable solution to that requirement. As engineers, we know that true deletion is really, really hard because data has a way of making copies, and there's caches everywhere, there's logs, data shows up in. Even when you try to delete it from a data store, it's not really clear. It actually gets deleted. So the technical guarantee of deletion is super hard. But often that's a red herring, because that's not really what you need to be doing. You just need to make sure that, again, I'm not a lawyer. And this is a legal question, of course. But often what you just need to make sure is the data is not going to be used or accessible. In some cases, some folks' interpretation is that the person's, for instance, someone might say that Manish registered for the service. That is a fact that needs to be forgotten. But the fact that Manish went and shopped for shoes and socks does not need to be forgotten, as long as what we forget is that it was Manish who did that. So in this case, my data got anonymized. And as long as all you're holding is anonymous data, you're fine. Maybe that works for you, maybe it doesn't. It kind of depends on your jurisdiction, your rules, etc. But for instance, going back to now your question with all those big caveats and examples, going back to your example, RTBF could be as simple as make sure the data is anonymized, or what you're storing, or going back to the tokenization thing, what you stored was not that this was Manish's shopping preferences, but this was user number 35's shopping preferences. And the only link between user number 35 and Manish is in the vault. Well, then that's the link you need to break. And now all you have is anonymous data and not data tied to Manish. So you've kind of, quote unquote, forgotten Manish and Manish's personal preferences and data in this case. Mm-hmm. In some cases, that may be sufficient. In some cases, not. Your mileage will vary based on your restrictions.
Mm-hmm. Right. Yeah. Like many of these types of questions, it's complex to say the least. So clearly in the data privacy vault world, you're storing these tokens within your application database or maybe your data warehouse. But at some point, whether that's in the user interface of your web application where you're showing account details or maybe some other part of your application, you need to essentially detokenize that data back to the original values. So what are the sort of technical measures in place to prevent unauthorized access of the data?
So in this case, your technical obligations are actually not that much different from what you would be, what you would need to implement if you were not storing tokens in this case. With some subtle caveats. So you obviously want to make sure that if you're showing some data to someone, they are authorized to see that data. Now, typically the way it would work is you've got a client that's making a call to a server, let's say, server making a call to a database, and you're deciding where you're going to put the access control gateway. So let's say you have the client talk to the server is going to do the check and then they basically realize, I need to give this data back to this client. So in this case, the question is really, how good an authentication system do you have? And normally that's the only question that engineers would ask when presenting this data. What you start seeing, of course, is that it's often a little bit more complicated than that. It's not that it's a yes-no decision in terms of data being presented. It's a question of like, what exactly are the attributes of the data that you are actually displaying to the user? So for instance, as an example, I enter my credit card number in a company. And when I call up customer service, the customer service person is logged into to respond to a specific ticket. They're going to make a call to their backend to say, I need to see Manish's payment details because I want to see what happened, the payment didn't go through or needs to be refunded or whatever. They need to know the credit card number. They are authorized to see the credit card number in this case, but the authorization is very specific. It is tied to the response to a specific support ticket that Manish entered. And also the authorization is not to see the full credit card number, it's to see a fraction of the credit card number. This is, if you were to develop a correct system, you would essentially have to make sure that you're kind of enforcing all of these controls. Now you can, of course, take this on in your server side. Some folks will implement it on the client side, which is, of course, the wrong way to do it. A better way to do it would be to implement it on the server side. The architectural pattern of the data vault would essentially say that the server only has the token because the server does not need to see the data. The server gives the token to the client, and the client has to present its claims, its authorization context, etc., to the vault to say, look, I have a token that says credit card number 1 for user number 35. I need to see the last 4 of the credit card number because I'm customer service agent, and here is the context for why I need to see it. And the data privacy vault can do the enforcement it needs to based on whatever your policies are, and can make sure that the access is properly logged, which is all what you need. Again, tying it back to residency, the fact that the user's data was used and displayed is often a requirement that this be logged. The fact that a user's data is leaving the vault and going out to, in this case, the customer service agent may also have residency restrictions. So like which customer service agent working in which geography is allowed to see this data. So all of these restrictions, whether they come from a internal compliance policy, whether it come from your regulations, are all obligations that you need to take on before presenting this data. And they're all the kind of thing that the data privacy vault as a pattern can help you achieve.
So how does that pattern help with this logging and auditing requirement that you mentioned?
So going back to the example, since the server didn't have access to the data, and therefore, like say, the server's database didn't have access to the data, and the server's logs didn't have access to the data, and any third party you're using to manage your server or any data warehouse that's taking a copy of your online database for analytical purposes to store in the data warehouse, etc., none of them have access to the data. Most of your data residency obligations are kind of sort of don't exist anymore. They exist only with the store of the sensitive data, which in this case is the data privacy vault. So you've translated those, just those specific requirements, but those are critical set of requirements. You've translated those onto the data privacy vault. You need to make sure that the accesses happening to the vault are in compliance with the regulatory frameworks. The accesses happening to the vault are properly logged, they're stored, and they're only allowed when they should be allowed for sufficiency of use, for like, am I using this in the right way, the right place, from the right geographies, all of those.
Mm-hmm. So it's basically, since you now have this single source of truth in the data privacy vault, it sounds like by creating that single source of truth, you're making a lot of the problems that you typically have because of data sprawl, they basically go away, because now all those challenges of localization, logging, sharing of data, revealing of data essentially exists just with the vault and nothing else within the infrastructure, because that's the only place that's touching the actual sensitive data.
That's right.
So you mentioned sharing data with third parties. So can you walk me through like how that works with the data privacy vault? So obviously we want to be able to still send emails or send a text message or whatever it is that where we need to share data with a third, maybe accept a payment. We need to share credit card information with a third party to carry out that transaction. How do we facilitate that process of sharing from the data privacy vault to the third parties without any of that data actually, coming through our systems?
Right, that's a good observation. Nobody builds anything these days completely entirely on their own. You kind of end up using a whole bunch of services that you need to for your system to work, and many of them would not work if they didn't have the data. Of first approximation to this problem is that you've got, let's say, a payment service you built up. You got microservice architectures, and that's the way you build things these days. So you've got a payment service, and whenever the rest of your services decide that the customers performed a transaction that they can be charged for, you tell the payment service, hey, by the way, user made a transaction, please go charge them. Nobody else in your system needs to know what the user's card number is. Only the payment service needs to know that. So that's great. You've already descoped your PCI obligations only to the payment service. But the way you solve it in PCI is like, do you really even need to hold the card number? You can use a payment gateway that handles all of that for you. In some cases, you're required to do that, use network tokenization, etc. That means you don't need to hold the card number at all, right? That's essentially the idea behind the way you would use a data privacy vault. Only it's not just for card numbers; it is for any data that is sensitive. And you can do it two ways. One is, let's go back to the payment example. You could say the payment service in the first card, payment service was the only thing that held the card numbers. Nobody else in your system needs to know what the card number is. They tell the payment service, it goes, retrieves the card number, and charges the amount to this particular card. In this case, you have a non-zero scope for PCI. You have the payment service that needs to be PCI compliant. When you transition to saying, well, does my payment service need to hold the card number? It doesn't, because I can use network tokens. It doesn't, because I can use payment gateway. What you're essentially doing is you're saying that I will talk to Visa to get this charge, but I don't need to contact Visa myself. I just need to talk to somebody else who will talk to Visa for me. That's the pattern you would use for any sensitive data. So to take an example of email that you mentioned, everybody does not need to know your customer's email address. Only, let's say, the email sending microservice does. So it can basically go to the vault, it can get the email, and go call the API to SendGrid, MailChimp, whatever email service you're using, Amazon SES, to actually perform the sending of the email. That's like the first cut we made to the card number example, where you just reduce the access to email addresses to just one service, this email sending microservice. But you could actually take that the next step as well. The email sending microservice just needs to hold a token to the email, and it's responsible for sending out the right body at the right time to user number 35 without needing to know what user number 35 is. So the analogy here would be that your data privacy vault would act like the email gateway, just like you had a payment gateway that takes a network token, it converts that to the actual call it needs to make with Visa. Similarly, the data privacy vault is kind of like the email gateway that takes a tokenized email address, in this case, as opposed to a card number token. It's a tokenized email address that it accepts and makes the API call to AWS SES or to SendGrid. And SendGrid doesn't need to know that you're using a vault. It just gets a call with the right authorization credentials, with the right email address. It can send out an email through this entire process without you needing to know what the email address is. So that's an example with an analogy to card numbers. Hopefully, it's a little bit more familiar.
Yeah, I think the payments example is a great analogy because that's something that lots of people have been doing for years. We're used to not directly handling credit card information. We rely on third-party services to essentially secure that, and then we use some sort of token representation to facilitate the communication. We're making API calls against it, those payment gateways, to actually issue transactions against the credit cards and accept payments, but we're never actually dealing with the credit card data directly. And it's taking that concept and essentially just applying that to any kind of sensitive data or customer data.
Exactly.
So you mentioned earlier this a little bit about analytics, and I wanted to kind of circle back to that. So in the scenario where we have multiple vaults, one in each country with a data residency law that we're operating in, how does something like global analytics work in that scenario?
Now, it's a very complicated question, but a great question. And of course, till you can answer the question about how analytics will work, nobody's going to use a pattern because given the importance of data, obviously, you need to make sure that your analytical workflows will survive intact after you move to a data privacy vault. So, complicated question. Let me touch on some high-level points at least that should give you a flavor of how you should approach this. So the first observation is that for a lot of the analytics that you currently do, you probably do not need access to any sensitive information at all. If I'm doing a basket analysis, you don't really need to know that Manish likes to buy socks and shoes. You just need to know that somebody who buys shoes is also very likely to be shopping for socks. So maybe you should show them an ad for buying socks, or show them a discount, or whatever you want to do on this. This is an example of an analysis where you could take your sensitive data out of your analytical stores and lose absolutely no functionality. So that's on the very simple end of the spectrum. Now, if you start getting a little bit more complicated, where you need to know shopping behaviors by age. Date of birth is a sensitive element. You probably have that around just for being able to compute things like this. But the observation here would be that you don't really need to know date of birth. You just need to know, in this case, age, which is still a sensitive element, but not quite at the same level as date of birth. If for no other reason, then there's a whole bunch of people who were born the same year I was born. So if you have an age or an approximation for age, if that's all you need for analytical use cases, that's kind of going back to the previous conversation we were having about tokens. A token should be random. It should not be something that's like an encrypted version of the data or some such thing. Encryption has its own values. In this case, that's not what you want, because it will bring other complications like key management and all for you, and then who owns the keys, where do you store the keys, etc. So a token is random, but that doesn't mean it has. It doesn't in itself also convey information that you're allowed to carry out of the data privacy vault. So for instance, when we take a look at HIPAA, date of birth is one of the 18 or 19, I forget exactly, but HIPAA protected elements. Year of birth is not. So you could, for instance, have a token that carries with it the year of birth, and you still want the token to be usable as a token, etc. So that's kind of technical details of how the token works. But for now, for this discussion, let's pretend that this is a token that also carries with it the year of birth encoded in a usable manner. Now you can perform your analysis on that you wanted to perform on age without needing the date of birth. A lot of what you want to do in analytics is not just do this analysis, but also use data. So going back to our previous example of how you were sending email, once you figured out that user number 35 has been buying shoes, maybe you should send them some promotion on socks. Now, thanks to the fact that you only had a token for user number 35, you don't know that it is Manish, much less Manish's email address, but you have a system that can send an email to Manish just because you identified them as such. So you can have a complete round trip to your analytical systems and back in a usable manner without needing to touch sensitive data. Now, of course, I'm glossing over a whole bunch of details. For instance, this wouldn't work if you were looking to actually find, say, some fraud use cases, for instance, wouldn't work, because you now really need to know that it's Manish who's just slightly misspelling their name and applying for more credit, that kind of stuff. So not all use cases work like this, but a good fraction of your analytical use cases probably would fall under this use case, this pattern, excuse me.
Mm-hmm. Right. So, as we start to kind of wrap up, I want to zoom out a little bit and see, what are your thoughts sort of on the future of data privacy? Do you think that the technical challenges around protecting customer data is going to be something that gets easier for companies to solve and address?
That's a tricky question because there's two aspects to how difficult it's going to be. Of course, that has to do with two components to it. One is the requirements. Requirements come from regulators, laws, etc. And I think we'll all agree that the regulatory frameworks are only getting more and more complex. They are biased more towards rights, more rights for customers. Security is similar. Security is becoming a more important problem. And companies I don't have to basically say it anymore. In fact, companies know it's a problem they need to handle. It's not going to go away suddenly. But again, that's the requirement side of things. On the concept of tools, best practices, etc., you're also seeing a whole bunch of things coming along. And obviously, if we are talking about the data privacy vault, so obviously that's one of them. But there's lots of patterns emerging, lots of tools that are emerging that are making this easier. So on the balance of it, is it going to be easier or harder? I don't know. But what I would point out is that you have to think about this strategically. You cannot assume that the requirements that have been in place is pretty much, or the requirements that are just about to come out is the only thing you will ever have to deal with. If you're thinking for the long term, which you ought to be, I suppose, if you're thinking for the long term, then you kind of have to make sure that you build your infrastructure in a way that is flexible. You don't buy a solution for the regulatory obligations on you today. You buy a solution that will allow you to not just implement the current regulatory obligations, but allows you to flexibly adopt new regulatory obligations. Moreover, it allows you to adhere to new regulatory obligations in a way that your other partners in business or your customers are going to continue to demand more features and capabilities out of your systems. So changing requirements, changing needs, at the same time, if you choose the right framework, you should be looking to do it in a way where you have the flexibility you need without taking on additional load every time the requirements change or the need for the data changes.
Absolutely. And I think that was well said. And I think that's a great place to leave it. So Manish, awesome. Thanks so much for coming on. I always enjoy anytime we get a chance to chat. I always learn a lot. And thanks for coming on to talk about data residency, and cheers.
Thank you, Sean. Likewise, it's been a pleasure.